Welcome to solverfy.
In how many ways can the letters of the word probability be arranged such that the vowels are together? So just writing out the word here, probability. Okay, so we have some repetition here, first of all. For example, we have two E's and we have two I's. One P, one R, one O, one A, one T1. Okay, now I'm going to mark the vowels. We have O, A, I, and there's also Y. Y is sometimes treated as a vowel, sometimes treated as a consonant. In this case, it sounds like a consonant, like a vowel, because it is taking that long E sound. Okay. So we have the vowels and we want to know how many arrangements there are. So first of all, how many arrangements are there in general when you have a list of things? Well, if they're all unique, then you say, okay, there are n factorial ways. N options for your first letter, n minus 1 for the second, anything except one you've already used, and so on until you get to the end and there's one left, and you multiply. There's an added complication when you have repetition. And for that, I'm going to use the multinomial coefficient. So the number of ways to arrange things when you have different types is n factorial over xk factorial, x1 factorial, rather x2 factorial, and so on for all of them. So you start with the n factorial ways that you would have if they were all unique, and everything on the bottom would just be 1 factorial, and then you deal with the repetition. So for example, if we don't think about the vowels for now, we just think about repetition, we have 11 letters here in the word probability. And there would be 11 factorial over 2 factorial because of the repeated letters. Now, okay, what about the vowels? What I'm going to do is I'm going to glue all of the vowels together and pretend they're just a single letter. And then I will find the number of arrangements of the word now. So we've got 5 vowels, 6 consonants, and I'm just gluing these together. So I no longer have 11 letters, I have 7, 6 consonants and this bunch of vowels. So how many ways can I arrange that? Well, there are 7 factorial over 2 factorial ways, because I have to think about the repetition of the E's, because 2 of the consonants are the same, they're both B. I'm not worrying about the I's for now, because those are within the vowel ball, so let's not worry. This is the number of ways to arrange between groups. In this case, the groups are vowels, P, B, L, and T, and R. So that's between the groups. Now I want to look at the arrangements within the vowel ball. Because I've just been treating them like a single letter, but there are different arrangements within that. I could have all of the consonants lined up in alphabetical order, and then I could say, okay, O, A, I, Y. That is one potential order here that would work. Or I could have all the consonants lined up in alphabetical order, and then A, O, I, Y. That would be a different order. So let's worry about the number of orders within the vowel ball. There are 5 vowels, 2 of them are the same, so it's 5 factorial over 2 factorial. Finally, I just multiply these to get the total number of ways. So the number of ways to arrange between the groups multiplied by the number of ways to arrange within the groups, giving us the solution 151,200. And there's also question 6. We don't have much information on that one, but it would be based on combinations. For example, if you're looking at this group of a total of 14 people, and you want to pick 5 of them without replacement, order doesn't really matter, that would be combinations. The formula for that is n choose r, n factorial over r factorial, n minus r factorial. But you're probably doing something more complicated than just finding out how many committees there are.